A difference of two squares is a binomial that can be factored into two other binomials. Because a square, by definition, is the product of two identical numbers, for instance, 16 is the square of 4 and 9 is the square of 3. The difference of two squares is two squares with a subtraction sign between them. For example, x squared minus 4 is a difference of two squares because both x squared and 4 are squares. 9y squared minus 25 is a difference of two squares because 9, y squared, and 25 are squares. To factor a difference of two squares, set up two binomials in parentheses. One separated by addition, another one separated by subtraction. Place the square roots of the first square to start each parenthesis, and the square roots of the second square to end each parenthesis. The first example, x squared minus 4, is factored into x plus 2 times x minus 2, because the square root of x squared is x, and the square root of 4 is 2. The factors of the second example, 9y squared minus 25, are 3y plus 5 times 3y minus 5, because the square root of 9 is 3, the square root of y squared is y, and the square root of 25 is 5. Another example, factor 49a squared minus 100. Answer, 7a plus 10 times 7a minus 10, because the square root of 49 is 7, the square root of a squared is a, and the square root of 100 is 10. Check work by multiplying the two factored binomials. Multiplication takes us back to the original binomial. Multiply 7a plus 10 times 7a minus 10. Using FOIL, 49a squared minus 70a plus 70a minus 100. Canceling negative 70a plus 70a, we get back to the original 49a squared minus 100. Sometimes we have to factor more than once. We call this factoring completely. And it means that in some occasions factoring is not finished on the first try and some more factoring should be done. For example, factor x to the fourth minus 16. Because it is a difference of two squares, factor two binomials. One addition, one subtraction. The square root of x to the fourth is x squared. The square root of 16 is 4. Now, the first binomial is a sum of squares and cannot be factored. The second binomial is another difference of two squares, thus turning the complete factoring into x squared plus 4 times x plus 2 times x minus 2. The square root of x squared is x. The square root of 4 is 2. Another example. Factor x to the 8th minus 1. First round. First binomial is a sum of two squares and cannot be factored. But we can factor the second binomial. Second round. We factor x to the fourth minus 1 and get two more binomials. A sum that cannot be factored, but we can factor the second binomial. Third round. We factor x squared minus 1 and get two more binomials to end the factoring. No more squares. The complete factors of x to the 8th minus 1 are x to the 4th plus 1 times x squared plus 1 times x plus 1 times x minus 1.